Listeners, today in physics, we learn circular motion and gravitation. In this, we are learn about uniform circular motion, centripetal acceleration, and centripetal force. First, uniform circular motion. What is basically it is? Uniform circular motion is the motion of an object traveling at a constant uniform speed on a circular path. Uniform circular motion body needs a lateral force such that it continuously changes its direction. For example, you can see in these diagrams the wall clock, the needles of the clock are continuously move in constant speed with constant time. It's change its direction, so it is in a uniform circular motion. The needles of the wall clock are in the uniform circular motion. And you can see in other diagram there is a man who rotates the rock in a circular motion. Anything which is moving in a circular path, it's called the uniform circular motion. When a body moves in a circular path with constant speed, it is said to describe uniform circular motion. The direction of velocity is directed along the tangent to the circle at the point. If at any point of a body is made free of force, it will move tangential to the circle at the point. But as the body moving along the circumference of the circle, there must be a force acting towards the center of the circle, and this called is the centripetal force. What is centripetal acceleration? Acceleration of an object moving in a uniform circular motion resulting from a net external force. The centripetal force AC, denoted by the AC. Centripetal acceleration, denoted by the AC. Centripetal means towards the center or center seeking. When a body travels on a circular path, its direction constantly change and thus its velocity change, producing an acceleration. The acceleration is directed radically towards the center of the circle. Centripetal acceleration, denoted by the AC. You can see. Now next is the centripetal acceleration, which is denoted by the AC, has a magnitude equal to the square of the body's speed, which is denoted by the V, along the curve divided by the distance denoted by the R, from the center of the circle to the moving body, that is represented mathematically, where centripetal acceleration, denoted by AC, is equals to V square divided by the R, where V is the speed and R is the distance. Centripetal acceleration has unit of meter per second square, m per second square. The force causing this acceleration is directed also towards the center of the circle and is named as centripetal force. For example, the direction of the velocity of an object at two different points, you can see in this diagram, are shown, and the change in velocity denoted by the change v is seen to the point directly towards the center of the curvature, where a acceleration is is equals to change in velocity and change in time. The acceleration is also towards the center is called the centripetal acceleration. You can see in this diagram there is v2 and v1. There is a change of velocity from center to the circumference. This car is moving on the circular path is called the acceleration of the centripetal acceleration. Now next is centripetal force. Centripetal force is defined as the radial force directed towards the center acting on a body in circular motion. In uniform circular motion, there must be a net force that must be applied to an object towards the center of a circle to make the object move round the circle. You can see in this diagram the velocity move tangentially to the center, which make the 90-degree angle and move in the circular motion. This center's force is called the centripetal force. For example, when a bucket containing water is rotated in a vertical circle, you can see in this diagram, water does not fall downward. Why? Because even when the bucket is at the highest point, the centripetal force is provided by the weight of water acting vertically downwards. Due to this reason, water does not fall. You can try this example by your own. You can easily observe the water doesn't fall downward direction. The mathematical representation of the centripetal force is if m is the mass of object moving in a circle of radius r with constant speed v, then from Newton's law of motion, F is equals to mass and centripetal acceleration, where AC is the acceleration produced by the centripetal force. Putting the value of centripetal force V square upon R in the above equation, and we get the F is equals to mv square upon R. Further examples of the centripetal force are:
At first glance, centripetal force looks strange. Consider this situation. The moon revolves around the Earth. The moon has a velocity as shown at a particular instant. However, to make this circular motion, the force should be perpendicular to the velocity, as shown.